Magandang araw po sa inyong lahat, and this time I am going to discuss on how to solve the shear and moment and how to draw the shear and moment diagram. Okay? Okay, ang sample po natin ay isang simple beam, okay, na may 6 meters na span and may 3 kilonewton per meter na load, no? Which is a uniformly distributed load na may span na 3 meters and a concentrated load of 10 kilonewton. Okay. So, but first, we're going to solve for the reactions before we can draw the diagrams. Okay. Okay. So, unahin natin yung solve natin una yung R1. Okay. Kung if we are going to solve for R1, of course, na definitely our pivotal point is at R2. So, ang equation natin is summation moment at R2 is equal to 0 positive clockwise. Okay? Kung saan iikot ang mga forces sa pivotal point. Okay. So, 0 is equal to R1. Okay? Si R1 times the perpendicular distance, which is 6 meters. Okay? So, from R2. So, 6 meters ang ano niya, ang distance from R2. Okay, kasi si moment is force times the distance, diba, ang equation. Okay. Positive siya, it is because ang direction niya is clockwise. Okay, clockwise siya. And then, minus 3 kilonewton, minus negative siya kasi counterclockwise ang direction. Okay. So, we have 3 kilonewton per meter times 3 meters kasi we're going to convert uniformly distributed load to a total uniformly distributed load. So, times 3 meters para makancel ang meters na magiging kilonewton siya. Okay? Times 4.5 meters. And this is the perpendicular distance. Okay? Of 3 kilonewton per meter. So, paano natin nakuha yung 4.5 meters? Kasi hahatiin na basta uniformly distributed load, ang distance niya from the pivotal point is nasa gitna. Okay, so since 3 meters siya, nasa gitna, that is 4.5 meters. 1.5, 1.5, and then 1.5. So that is 4.5 meters ang kanyang perpendicular distance. Okay? Okay, next is 10 kilonewton. So, negative kasi counterclockwise. Okay? And ang distance niya from the pivotal point or from R2 is 1.5 meters. Okay? So, that is the equation. Okay? So, i-transpose lang natin. Okay, ang negative magiging positive lang, no? Okay, so transpose natin sa kabila. Okay. So magiging R1 times 6 meters is equal to 3 kilonewton per meter times 3 meters times 4.5 plus 10 times 1.5. So the result of R1 or the value of R1 is equal to 9.25 kilonewton. Okay? 9.25 kilonewton. Okay. So next, we're going to solve for R2. Okay? So si R2. Since isa na lang ang unknown, pwede natin hindi gamitin yung summation moment and go directly sa summation forces. So since wala tayong forces horizontal, so 0 siya. So vertical ang consideration. So summation forces vertical is equal to 0. Positive upward. Okay? So unahin natin yung unknown, which is R2. Kasi si R2 is upward force, so positive siya. Okay? Next is the R1, which is 9.25. Again, positive force kasi upward siya. Plus 9.25 kilonewton. Minus 3 kilonewton per meter times 3. Again, Uniformly distributed load convert to a total uniformly distributed load by multiplying by its span. Okay? So, makancel si meter, so kilonewton lang matira. Minus 10 kilonewton, negative siya kasi going down. Pati si uniformly distributed load, going down. So, negative silang dalawa. Okay? So, our R2, the value of our R2 is 9.75 kilonewton. Okay? So, that is our R2. Okay? So, from here, pwede na nating i-drawing ang ating ang ating diagram. Okay. So unahin nating i-draw ang shear diagram. Okay? Shear represents V. Okay. So first we have V1. So we are going to start from the left to the right. Okay? So makikita natin yung unang force, okay, is ang R1. Okay? So ang value niya is 9.25 and the direction is going up. So positive. V1 is positive 9.25 kilonewton. Okay? So ang drawing niyan, going up. Yan, that is going up. Kuha. Nilagyan ko lang ng arrow para sa direction. Okay. Okay? So next is our V2. Okay? From 9.25, no, itong reaction 1. Ang susunod na force is si 3 kilonewton per meter. Okay? So kung makita niyo yung broken lines, no, mga broken lines. Kasi ito yung mga dinadaanan ng mga forces. Okay? Yan. So negative kasi going down. Okay? Negative 3 kilonewton per meter times 3. Kasi you're going to again to eliminate meters kasi para maging kilonewton lang siya. Okay? So 9.25 minus 3 kilonewton times 3. So ang answer po, our result is 0.25 kilonewton. Okay? 0.25 kilonewton. How to draw if no ang ating load is a uniformly distributed load. Kung mapapansin niyo, per meter siya. Every meter meron siyang 3 kilonewton. Okay? 3 kilonewton. So, may mga degree kasi sa mga lines, no? Okay. Kung paano siya i-draw, naka-slant siya. So, naka first degree. Okay? Tawagin natin first degree siya. Since positive, andyan lang siya sa taas ng 0. Kasi pag negative siya, below 0. Okay? Kaya may 0 line eh. Okay? So, 0.25 kilonewton. Kasi uniformly distributed siya, kaya naka-slope, no, or naka-slant siya. Okay. Para madaling maintindihan. Okay. So next, walang load. Ito 1.5 meters from the edge of 3 kilonewton per meter hanggang sa 10 kilonewton, wala siyang load. Okay? Wala siyang load. So, ang drawing natin dyan is naka straight line 0. Okay? 0 siya. Okay? 0. Yan po, no? That is how to draw or to interpret the diagram. Kasi wala man siyang load. So maging 0, straight line lang siya. Hanggang sa 10 kilonewton. Okay. So from 10 kilonewton, no, from 0.25 kilonewton pala. So next to that is the next load is 10 kilonewton. Going down, negative. Okay? So negative 10 kilonewton. So ang result is negative 9.75. Going down. Since negative siya, this is below 0. Kasi above 0 is positive, below 0 is negative. Okay? So dyan po ang kaniyang location. Negative 9.75. Okay. So next, again, from 10 kilonewton to the reaction 2 is walang load. Okay, kasi concentrated lang siya eh. Walang load, 1.5 meters na distance, walang load. So the same lang sa kabila, no? Straight line, 0 kasi siya eh. Okay, 0. Yan, 0 siya. Okay. So now, we're going to solve for our last, no, B4. Okay. Okay. From negative 9.75 kilonewton, okay, meron tayong positive 9.75 kilonewton reaction. Kaya positive kasi going up siya. Okay? So, that is equal to 0. Yan. Ayan, na-close na natin ang diagram. Kasi we're going to close the diagram eh. Kasi pag hindi natin ma-close ang diagram, so something wrong with your solution. Okay? So, next is the moment diagram. How to solve the moment diagram? 'Di ba ang moment is ang equation is force times the distance. But this time, para hindi kayo malito, solve for the area of these figures. Okay? So, meron tayong isa, dalawa, tatlo. Okay, we have 1, 2, 3. Lagyan natin na ng number, no. Okay, para ganito na lang. Lagyan natin ng number. Okay. So, wait ha. Yan. Meron tayong 1. Meron tayong 2. Yan. And 3. Okay. So, meron tayong tatlong figure, no? 1, 2, 3. Area lang nito, at saka area nito, at saka area nito. Yan, madali lang ang moment. Okay? Okay. So, next is to solve for moment, no? Okay. So, meron tayong area 1, 2, 3. So, tawagin na natin yung M1. Okay. So, ang formula nito is 1/2 times 9.25 ito plus 0.25 itong point na to times the distance which is 3 meters. Okay? 3 meters. And that is 14.24 kilonewton meter. Okay. So, change natin to. Kilonewton meter. Okay? Kaya kilonewton meter kasi force times the distance nga. No? Force times the distance. Kilonewton is the force times meter is the distance. Okay? Okay, so how to draw that one to the how to draw the line, no? Okay, mapapansin niyo sa taas is naka first degree siya, naka slope. Okay, kasi ang load niya is uniformly distributed load going down, naka first degree, and sa moment nagkaroon na siya ng curve konti. So, tawagin na natin siyang second degree. Okay? Okay? First degree, second degree. Okay, may konting curve lang siya. Okay? That is 14.25 kilonewton meter. Okay? Yan, that is our M1. So, next is our M2. Ayan. Kung mapapansin niyo sa taas, walang load, 0, from next to 0 is first. Okay? Straight, naka-slope siya, naka-slant siya. Okay, explain ko muna bakit naging 14.625. Okay. From 14, I mean, the area, no, or M2, ang area niya is, or ang force niya is 0.25 times the distance of 1.5 meters. So, ang answer niya is, or ang value niya is 0.375 kilonewton meter. Okay? So, this time, kaya nagiging 14.625 kasi we're going to add the result of M1 to M2. Okay? Hindi sa lahat ng panahon positive siya. Kasi minsan may result na negative siya. So pag negative, i-subtract lang, no? I-subtract lang. Kasi but this time ang result niya is positive. So i-add natin. So we have 14.625 kilonewton meter. Kung mapapansin niyo umaangat siya. Ito 14.25, ito naman 14.625, tumaas ang moment. Okay? Tumaas ang moment. Okay. Okay, so next is the last rectangle. Okay? The last rectangle. So we have negative, kasi negative siya, no? Negative 0.75 times 1.5 na distance. Okay? So ang result niya is 14.625 kilonewton meter. Zero ang result. Okay? Kasi from 14.625 minus negative, minus 14.625, zero. Kasi dapat may balik natin yung, ma-close natin yung diagram. Okay? We have to close the diagram from 14.625, 14.625 to 0. Kasi pag hindi nyo na-close ang diagram, mali ang iyong solusyon. Okay? Okay? So, yan po. So, therefore, our maximum shear is 9.75. Nasa R2 siya. Okay? Itong mga negative signs, hindi ibig sabihin nga negative ang kanyang effect. Okay? So, kumbaga, location lang ng diagram. Kung saan siya, no? Or direction. Okay? Kung saan siya nakalocate. And our maximum moment is, napansin niyo, no? 14.625. So, ito yung pinaka-critical sa moment. Ibig sabihin, pag ang moment po is bending. Okay? Moment is bending. And, ang shear po is critical siya sa support. Okay? Mapapansin niyo critical siya sa support. Okay? So, sa R1, we have 9.25. Sa R2, we have 9.75. Okay? Na shear. Okay? So, ang effect ng shear dito sa sa support is mapuputol siya. It's a moment naman, ang effect niya is bending, mag-bend siya. Okay? So, by having this diagram, madali nyo makikita kung saan critical ang structure or ang beam. Kung i-apply natin ang reinforced concrete, so madaling makita kung saan i-reinforce ang structure or ang beam. Okay. Okay, madali siyang makita ang structure. Okay, so sana ay may natutunan kayo sa aking discussion. At dyan po nagtatapos ang aking presentation. So maraming salamat and God bless.